welcome to the Explainer. Today, we are unpacking a truly monumental shift in technology. For the past couple of years, we've all gotten pretty used to prompt-based AI, right? You ask a chatbot a question, and it spits out an answer. It's cool, it's useful, but it's fundamentally reactive. Well, today, we're looking at the next major evolution, agentic AI. We're talking about autonomous machines that stop waiting around for your every command and actually start taking action to achieve your goals entirely on their own. It is fascinating, it is immensely powerful, and honestly, it's going to change absolutely everything.
Here's our roadmap for today's Explainer. First, we're going to map the massive leap from chatbots to agents. Then, we'll open up the hood to look at the exact engine powering this autonomy, the PRAO loop. After that, we'll break down the anatomy of an agent, look at why keeping a human in the loop is absolutely critical for safety, and finally, we'll land on the heavy ethical stakes of what happens when these autonomous systems inevitably fail.
Part 1. From chatbots to agents. Okay, let's dive right in. To really grasp where we're headed, we first need to understand what we're leaving behind. And it brings up this massive, provocative question. What happens when AI stops waiting for our prompts and starts acting on its own? Up until now, everything has started and ended with you. You type, the machine types back. But true machine autonomy means handing over the keys and letting the software actually take the wheel.
So let's lock in a core definition. An AI agent is essentially a system set up to perceive its environment, reason about what to do next, take actions using specific tools, and then observe the results of those actions. But the real magic, the absolute game changer, happens at the very end. The agent repeats this loop completely on its own until your overarching goal is finally reached.
The difference here is honestly wild. At level 1, with your standard chatbots, you are doing all the heavy lifting. You decide what to ask, you map out the steps, you figure out what to do with the final output. But at level 3, with agentic AI, the AI decides the workflow. It picks the tools, figures out the order, decides if it needs to retry a step that failed, and it alone determines when the job is actually finished.
The best way to think about this is like cooking. A standard AI workflow is like a recipe. You have the exact steps written out in advance, and you have to follow them perfectly to get your meal. An AI agent, on the other hand, is like hiring a personal chef. You just give them the goal. Hey, make dinner for 8 people who love Italian food. And then you literally leave the kitchen. The chef, your agent, creates the menu, goes shopping, notices they're out of tomatoes, pivots to a new sauce, uses their own tools, and serves the meal. You are completely surrendering control of the how just to achieve the what.
But look, surrendering that control obviously comes with some major trade-offs. Traditional workflows are super fast to build and highly predictable. You put the same input in, you get the same output out. But they break the second something unexpected happens. Agents handle surprises beautifully because they adapt in real time. The catch? They take way longer to build, they need incredibly careful setup, and their predictability is pretty low. You don't always know exactly how the agent is going to solve the problem, you just know that it will try. Moving on to Section 2, the PRAO loop engine. So how do these agents actually figure things out on the fly? Let's step into the engine room. This is the PRAO loop, and it is the absolute heartbeat of an AI agent. First, it perceives. It takes in an input, like a prompt or data from a sensor. Second, it reasons. It uses a large language model to break the problem down and decide the very next step. Third, it acts. It actually fires up a tool, like searching the web or running code, because without this step, it's just thinking, not doing. And finally, it observes. It looks at the results of what it just did, updates its game plan, and decides if it needs to loop back around or if the goal is completely met.
Let's ground this in a real-world scenario. Imagine you tell your agent, find me the absolute cheapest flight to Vancouver. The agent perceives that goal, it searches normal flights, but then it reasons, wait, this one specific airline hides its prices on the big aggregator sites. So it acts. It actively goes out and fetches that specific airline's hidden website, it observes the new data, compares the prices, finds you the cheapest option, and boom, task complete. It looped multiple times, adapting to new info, and you didn't have to lift a finger.
Section 3. Anatomy of an AI agent.
That looping capability is incredible, but an agent needs some specific, almost biological parts to actually pull it off. Every true AI agent requires 4 distinct components. They need a goal, built right into the system prompt. They need tools to interact with the outside world. They need memory to keep track of context. And they absolutely desperately need guardrails, the rules and limits. Because without all 4 of these things, you don't have an agent. You just have a really smart, but totally powerless chatbot.
Let's start with the goal, because it's the foundation.
Think of it like an employee handbook that you hand to the AI before its very first day on the job. Before a user ever even types a single word, this hidden system prompt tells the agent exactly who it is. Maybe it says, "You are Aria, a highly professional customer service rep." It defines the agent's exact purpose, its scope of what it's allowed to discuss, and strict behavioral rules for handling, say, an angry customer. It dictates not just what to do, but who the agent fundamentally is.
Next up is memory. Now, if an agent tries to load a massive database of everything it's ever learned all at once, it just gets overwhelmed. Semantic memory is way smarter. It uses vector embeddings, which is the tech behind RAG, or Retrieval Augmented Generation, to instantly find the closest match to whatever it's working on right now. It pulls only the useful, highly relevant pieces of information into its active mind for that specific task. It's incredibly efficient.
Section 4. The human in the loop.
Giving software a goal, tools, and memory is obviously very powerful, but let's be real, it's also inherently dangerous. That brings us to the immune system of AI, guardrails. We've got hard limits, which are absolute stone walls, like never spend more than $50. We have soft limits that a user can easily tweak. We have scope restrictions to make sure a customer support bot doesn't suddenly pivot to giving medical advice. And, crucially, we have confidence guardrails. If the agent fails a search 3 times in a row, a confidence guardrail literally forces it to stop and ask the human user for help, rather than just blindly guessing.
The whole trick here is balancing raw efficiency with absolute safety. A fully autonomous agent? It runs from start to finish, it is lightning fast, but the risk is huge, because if it makes one bad decision early on, that error just snowballs. The alternative is designing a system with a human in the loop. This means the agent intentionally hits the brakes at specific, predefined checkpoints and literally waits for a human to review, approve, or course correct before taking the next step.
So where exactly do you put these checkpoints? Well, you definitely want the agent to pause before any irreversible action. Think sending a mass email to your entire client list or deleting records from a database. You also want to pause when the AI's confidence is slipping, when the scope of a task suddenly gets way bigger than expected, or right before any high-cost action, like running a massive API query that could rack up a $1,000 cloud bill in 5 minutes.
And that brings us to Section 5, Failures and Ethical Accountability.
Because here is the scary reality. What happens when those guardrails actually fail? Since agents loop autonomously, their failure modes are uniquely dangerous. Take a hallucination chain. The agent invents a fake fact in its very first loop. By loop 5, it has built an entirely fabricated but incredibly authoritative-sounding report based completely on its own lie. There's scope creep, where an agent asked to draft a simple welcome email decides to deeply research the recipient's entire personal history. Or an infinite loop, where it just searches the exact same useless terms over and over, burning through time and server money until a human finally unplugs it.
Which brings us to this ultimate, deeply profound dilemma if an AI agent makes a mistake. Say it gets stuck in an infinite loop and runs up a $10,000 server bill, or it hallucinates a terrible recommendation that causes your business to lose a major client. Who is actually responsible for that?
Let's look at the suspects here. Is it the user's fault? They gave the goal and hit go, but did they truly understand what the agent was capable of? Is it the developer who wrote the system prompt? Sure, but it's literally impossible to code for every single edge case. Is it the company that deployed it without enough red warning labels? Or, and this is wild to think about, is it the AI itself? Can you even hold a system with no consciousness accountable? The real truth? Right now, it depends, and our laws just haven't caught up to the tech yet. It is a thrilling but definitely terrifying frontier. Thank you so much for joining me on this explainer today. Keep asking those big questions, and I'll see you next time.